Students, welcome to Talk on Civil Engineering. Let us discuss about extra winding from transportation engineering. So this extra winding usually provided at horizontal curves. At horizontal curves, the extra width is provided for the road compared to the straight path. Okay, so this extra width we are calling as a extra winding. Okay, so here this extra winding is a combination of mechanical winding plus the psychological winding. That means we are providing the winding or the extra width because of the mechanical reason and the psychological reason. So let us see how we will provide how much width extra will provide for the mechanical reason and why we will provide for the mechanical reason. Okay, so this mechanical winding, so here we'll denote the extra winding with WE. If W is equal to extra winding, then the formula of extra winding will be WM plus WPS. So WM is nothing but your mechanical winding and WPS is a psychological winding. Okay, so coming to the mechanical winding, so this mechanical winding, generally it is provided for the off tracking reason of the vehicle. So what is off tracking? So if you see at the horizontal curves, so this off tracking takes place. The off tracking means the rear wheels will follow different path than the front wheel. Generally in straight path, what happens? The rear wheel will follows the front wheel path, but at horizontal curves, the rear wheel follows the different path than the front wheel. So therefore, the rear wheel will follow different radius, that is of shorter radius than the front wheel. So that means front wheel have the more radius than the rear wheels. So if you see, let us try to draw a diagram so that we can understand. So at a horizontal curve, let this be the front wheels. So these are the front wheel, and here comes our center of the vehicle. So these are the rear wheels. Okay, so this is how the vehicle goes at horizontal curve. Okay, and so if you draw the curve from each wheel, draw the line. So this is how your curve from the front wheel, right? And this is how the line goes. This is how the line goes for the rear wheel. Okay, so similarly for other wheels also. So from this we can understand that so the two wheels, the front wheel and rear wheels, are having different paths, different curves. Okay, so we draw the radius of it. So let the front wheel radius. So this is the front wheel radius, let it be R1, and this is the rear wheel radius, let it be R2. Okay, and the length of vehicle, let it be L. Okay, so the difference between R1 and R2 will be the length of vehicle, right? So the length of vehicle will be R2, and whatever the difference between R and R2, so this will be the mechanical winding. This much winding should be required. So let it be WM, and here also this is WM. So this much mechanical winding that we need to provide. So this is called the off tracking. So this is what the scenario happens while the vehicle traveling on the horizontal curve. Okay, so let us try to calculate or derive an expression for this WM, right? So here from it looks like a triangle, if you see. So it looks something like this. So this is R2, this is R1, and this will be your L. Okay, so we can use Pythagoras theorem. So from Pythagoras theorem, we know that R1 square is equal to R2 square plus L square, right? And we can write R1 as R2. So here, so it is R2 plus WM, right? So R2 plus WM whole square is equal to R2 square plus L square. Okay, so because we know R2 is equal to, so here we know R2 is equal to R1 minus WM, or R1 is equal to R2 plus WM. So we can use another one, either you can change this, you can replace at R2, you can replace R1 minus Wm, or at R1 you can replace R2 plus Wm. Okay, so let us elaborate this equation. So it is the form of a plus b whole square. So it is R2 square plus 2 R2 Wm plus Wm square is equal to R2 square plus L square. Right. So here you have one R2 square, either on the side also having R2 square. Let us cancel those two. So you will left with 2 R2 Wm plus Wm square is equal to L square. Okay, and this is the equation. Generally, this is the equation for the mechanical widening, or for the off tracking of the vehicle. So this much Wm you need to provide. But from this equation, we can neglect these terms. This term can be neglected because for larger radius, so your Wm square is very small in the sense 0.002 like that. So it is very small. So therefore we can neglect that value. So therefore neglect Wm square. So here we are neglecting Wm square, and also for the same reason, for the larger radius, usually your R2 and R1 will be approximately equal to your mean value. Okay, so let us replace in this equation. So your R2 will become just R. The R, it means the mean radius, Wm, plus we are neglecting this Wm square because this value is very small. Actually, to your Wm, the mechanical winding with mechanical winding itself, you will get in 0.06 like that. So 0.06, 0.04 like that. So in after after point of 2 decimals. So square root of that, you will get much smaller value. That is the reason we are neglecting that. So is equal to L square, and so send 2R to that side, we'll get Wm. So Wm is equal to L square by 2R. So this is a formula to provide for the mechanical winding. This is the formula we are going to use. And here we have calculated for the single lane, only one lane we have considered. If the road having multiple lanes, then we'll consider the number of lanes as well. If you consider number of lanes, the formula will be N L square divided by 2R. So this is a formula for the multiple lanes for mechanical winding itself. Okay. Or suppose if you want the clarity why we have negotiated or neglected this Wm square, just do a calculation taking. So here, as per IRC, for commercial vehicles, we'll consider L is equal to 6.1 meters. Okay, so 6.1 meters. So let us, for example, so for in Wm, let us put values as L is equal to 6.1 square, and radius for a random, let me substitute 300. Okay, so what will be the value? 6.1 square divided by 2 into 300. See, it is 0.062. And if you consider the square root of this, so how much value you will get? 0.062 whole square. So it is 0.0038. So that's the reason, since this value is very less, is very close to 0. That's the reason, and very small. This is very small, right? This is very small. So that's the reason we have neglected that value. That's the reason this Wm is neglected in that equation. Okay, so just for understanding purpose, I have taken this example. So now you got clarity how to calculate this, how to derive this mechanical winding, right? Now let us see how we can calculate the psychological WPS, the psychological winding. So WPS. So WPS in the sense psychological winding. So this psychological winding is provided because of the psychological reason of the driver. So what happens at horizontal curves? Usually there is a tendency of driver driving close to the outer edge of the curve. So in order to have better view on other side, and in order to avoid a collision from the opposite vehicle, so the driver usually will follow the outer edge of the curve. Okay, and also some extra width for crossing and for overtaking. So generally we won't allow overtaking or crossing at the horizontal curves, but we know the Indian psychology, so they won't follow these rules. Most of them won't follow these rules. They want to take over wherever they feel comfort, right? So that's the reason we should also consider this for the safety reason. So that's the reason IRC provided. That's the reason IRC provided, based on its research, it provided an equation for the WPS that is equal to capital V 9.5 under root R. So here V is in kilometer per hour and R is in meters. So you have to substitute V in kilometers and R in meters itself. Okay, so directly by using this IRC provided formula, we can calculate what is the psychological winding. Okay, now coming to complete equation for the extra winding, WE is equal to, so the mechanical winding WM plus the psychological winding WPS, so which is equal to NL square divided by 2R plus capital V 9.5 under root R. So this is the equation for the mechanical winding. Okay, and few more things we need to remember that. So if the radius of curve is less than or equal to 50 meters, that means for a sharp curve, so the extra width or the extra widening is provided at inner side of curve. So if it is a sharp curve that is having a less than 50 meters, so the extra widening is provided inner side of the curve, and the radius is greater than 50 meters, then extra widening is provided on both sides. So both the sides, the extra widening is distributed. Okay, so this is how we are going to calculate the extra widening at an horizontal curve. Thank you all.